into it today. Yes, so we're going to start off with doing this warm up, then we're going to go into the notes and hopefully have time for practice number one. So the question is really a simple one. We talked about this on Monday. So who can tell me what are the steps for graphing a line? What do you have to do to graph a line? Who remembers? Everyone has forgotten. No one remembers. We had class on Monday?
You
Go ahead.
yeah. Um First you have to identify your variables.
Okay.
Um and then I guess you would determine um what do you
So you have your
I guess
variables, and then what are you
mhm.
what are you going to do with that information? How's that going to help you with the graphing? What do you do with it? How do you use it?
um you determine the points.
Okay. All right. And how am I going to do that? How do I know where to start? If I'm using my equation, how do I start? What is my first thing I have to do? So in your notes, it's organized as first, next, and last. What are your three steps? There are only three.
Um Label your axis.
Okay. Yeah, labeling my axes might be helpful. Absolutely.
Mm,
I know she was not in class alone on Monday. I know some of y'all were there. Nobody wants to help out? Really? Y'all just gonna be like, nope, I'm good. Just let her. Okay. All right. Here are our steps. So we were thinking about tables, I think, and that's fine. We can use a table as well to make a line. But if you have an equation, your first three steps are these three steps right here, right? You're going to locate the y-intercept, which is your b, and then you're going to move to your next point using your slope, and then connect your points with a straight line. Those are the three steps I was kind of looking for making a line. We're going to practice that skill today. We're going to keep working with that skill and that idea of how to make a line from an equation. So what we talked about on Monday, just to recap, is that this is the standard equation for a line. We call this the point slope form, or the slope intercept form, excuse me. This is a slope intercept form. You don't need to necessarily know the name of this, but it's called the slope intercept form because it tells us the slope, m, and the intercept, b, right? Your b is where you start on your graph. The intercept is where the first point is on your y-axis, okay? If there is no b, then the intercept is 0. And then your slope tells you how to move. How does your slope tell you how to move? Well, your slope, which is indicated by this letter M, is the rise over the run. So your rise tells you how you go up or down. You go up if it's positive, down if it's negative, and then you go to the left or the right for your run. So you go to the right if it's positive and to the left if it's negative. All right, so these are the things that we have to kind of keep in mind as we go through and practice this idea. All right, so um, what you guys should have open now in order for us to continue working on this together is your notes in your week 10 folder. So I'll go show you guys how to navigate to that. Oh, sorry, let me clear this drawing so that it's not all over the place. So week 10, your graphing linear equations folder. So it's the only red folder in your Math Skills 4 class. Make sure you scroll down to the linear equation graphing notes. All right, so we started these on Monday. We're going to finish them today. And so I need you guys to open up those notes. Okay, and we are on page 3, I believe, or 2. Yeah, we're just on page 2. So we're gonna review what we did last on Monday and then start new with these other examples that we have here. Okay, so I'm gonna write back in a little bit of these notes here to kind of help guide us as we do these next couple steps. Let me put it right here. I'm gonna have to move it anyway, but it's okay. All right. So my standard equation for a line is y equals mx plus b. This m and this b aren't real variables. They're just placeholders for right now, just so you understand the format that you're kind of looking for your equation, okay? The m, again, is your slope. It tells you how the line, how slanted the line is, right? That's what the slope is. And your b is the y-intercept. Right, so when we look at this equation right up here, y is equal to -1/2 x plus 4. We know that our m, right, which is the coefficient in front of the x, right, it's the number in front of the x. That's what coefficient is, right? The number in front of a variable is -1/2. That is my slope. My b is 4. So the location of that point on my graph is 0 because I'm not moving at all left or right. I'm just going up to the 4 on the y-axis. 1, 2, 3, 4. So that's that first point on my graph. To make the next point on my graph, I use my definition of slope. Slope is equal to rise over run. It is a fraction, right? It's a rational idea. Rise is up or down, run is left or right. And my rise is -1, so that means I go down by 1, and then I go to the right by 2 to make my next point. And that's what I keep doing. I keep following that same pattern. Down by 1, to the right by 2. Down by 1, to the right by 2. And that's how I'm able to make that graph. The same thing is going to work over here with this line. This line, it says y is equal to -x minus 3. There's no visible number in front of this x, but anytime I see a variable, I have to assume that the number 1 is in front of it. And so my slope is -1. My b, right, which is what follows the x, is -3. So that point is located at 0, -3. So that's where I put my first point on my graph. Using the same idea of slope, right? I'm going to go down by 1 and to the right by 1, down by 1 to the right by 1 to create my next few points, right? So this is what we did on Monday. These are the ideas we need to work with today as we continue to build on this idea and make more graphs. The only way to get comfortable doing this is to do it a bunch of times. So that's what we're going to do. We're going to work through making different graphs and learning different scenarios, and making sure that if we have any questions, we're asking them, right, as we go through this process. All right, so we're going to try it with this first one for today. The equation is y is equal to 4x plus 1. So what do I know from this equation? What can I learn? Can anybody tell me what I know by looking at this equation? What can I find out? What does it tell me? 4x plus 1. What do I know? Okay, let me ask more specifically then. I'll ask a person to help me out then. Let's see. Marvin, what can you tell me about this equation? What does it mean? What is it telling me? What can I find out about 4x plus 1?
Okay, so when they say y equal to 4x plus 1, so
Uh-huh.
the way how I know about basically m is equal to m is 4x or x and b basically 0.
M is what?
1. No, I would look at it say for x and m and say like 4
M is,
x and not b
M is
equal
4 or
here.
4x?
4x that basically that go to that will
So
go to
what
here.
is M?
M is a -1 half.
So up here it's -1/2, right?
Right.
Not 1/2 x. So what is it? What is the M here? Is it 4 or 4x?
Yeah, 4. Yeah, 4.
4,
4x,
right?
yeah.
So M is always just the number in front of the x, right? Okay.
Right.
So M is the number in front of the x. Perfect. All right. Thank you, Marvin. So my M is 4. Okay. What does the letter M stand for? Who can tell me that? What does the M stand for? What does it tell me about the line? What is the word that I've been using to describe M? M is my what?
Saying 4 is your rise.
M is your slope.
Good. M is my slope. Okay. So my slope tells me how much the line is slanted. Okay. It's my slope and how much the line rises over runs. Okay. So remember, so your slope is a ratio. So even though I have a whole number here for my M, I can make it into a fraction. How do I turn a whole number into a fraction? What kind of witchcraft is that to turn a whole number into a fraction?
Turn a whole number into a fraction.
How do I turn a whole number into a fraction?
Don't you just put a 1 under there?
A whole number.
I just put a 1 underneath it. That's right. It's not witchcraft at all. Right? I just have to put a 1 underneath, okay? So now I know that my slope, when I'm ready to make my next point, I have to go up by 4 and to the right by 1, okay? Rise over run. Okay, but first I have to know where I begin my graph. Where do I begin? And how do I know? I always begin at my B. What is my B in 4x plus 1? What number represents the B?
1.
1. So I'm going to start on my graph at the point that is 0, 1. All right, so I'm going to move down my notes here. I'm going to erase them.
You said 0, 1. Okay.
I'm going to erase some of these things I don't need. Right, because I have it rewritten in other places. Okay, so I have my slope identified for me. I have my, good, perfect. I have my y-intercept identified for me. It's going to be at the location 0, 1. Remember this address that I have here. I always love reviewing this because we need to get used to it, right? This is the location of this point on the x-axis and on the y-axis. So what I do is I start at 0, 0. I always start there for every point. But for my x, I don't have to move because it's at 0. So I just go up to 1. And that's where I create my point. And I can do that in Kami using my drawing tool. I can use my drawing tool, get a nice big red dot, and put it right here at 1. Okay, my next point, in order to make my next point, I have to use my slope. My slope is 4 over 1. So that means I'm going to go up by 4, 1, 2, 3, 4, and then to the right by 1. And that's where my next point goes. Right? 2 points is enough to make a line. So I'm going to go back to my shapes tool. I'm going to select the line function, insert line. And I'm just going to go ahead and connect these 2 points together to make my line. Might make it a little bit longer just for fun. Let's see. Going to go like this. That's my line. Okay. So those are your steps to graphing. You always start with your B. Your B is always indicated by the number after the X value. If there's nothing after the X, your B is 0. You see, you start at 0, 0 at the origin point. You use your slope to go up and over according, or down and over, depending on what if your slope is positive or negative. And you plot another point. Then you can connect those 2 points together to make the line. Okay,
So I have a question.
go right ahead.
With the line, does it matter which end you make longer?
Absolutely not, no.
Okay, cool.
Not at all. Right, if you were drawing this on pen and paper, right, which is how we normally do this, I would always tell you to make sure that your line goes through the entire graph, right? So that it doesn't just end in the middle of the graph like this does. It would go through the entire plane, but we don't have the control that we do when we're on pen and paper to use a ruler and just draw the line, right? So here, it doesn't matter, right? Just as long as you're connecting those dots, that's enough.
Okay.
Okay. All right, let's try this next graph. What is my slope on this next graph that says y equals 1/2 x? What is the slope?
Mm, 5.
Not just 5, what is it? It's the whole thing. What do you see before the x? Everything you see before the x is what?
1/5 x.
1/5.
1 over 5. Okay.
Exactly. 1/5, 1 over 5. Yep. Right. You need the whole thing. Whatever you see in front of the x is your slope. Right. And this one is already a fraction. So it gives you, it makes it a little bit easier. You're going to go up by 1 to the right by 5 when you make your points. But where am I going to start on my graph? What is my B? What do I see after my x?
Nothing.
Nothing. So my B is 0.
0?
Mhm.
Okay.
So I'm going to start in the middle. My first point is going to be in the middle here at 0, 0. To make my next point, I'm going to go up by 1 and to the right by 5. 1, 2, 3, 4, 5. Okay, those are my points. And now I can connect them.
Up 1.
All right, any questions about these two? All right. So the ones that we've seen so far are all very normal lines, right? If they go up to the right, even if they're just slightly, like this last one, they have a positive slope. If they come down to the right, they have a negative slope, right? Which we can see, this is negative, it's coming down, it's coming down. These two are positive, it's going up even slightly. This one is going up very greatly, okay? Now we're gonna see some really different examples, all right? Prepare yourself. These are special cases, all right? So this one says that the line is y equals 3. So I don't have an x, that means I don't have a slope, all right? Or my slope is going to be equal to 0 in this case, right? Because I have just 3, which means I know what my b is. So I can put a value in for my b. Because there is no x value, I know that I have a b, but I actually do not have a slope, okay? And this slope is not equal to 0, it's actually not existent, right? Well, I'll show you why that is in a second. Let me just draw this line first. So I know that I can start here in the middle, not in the middle, but at 3 is my only point that I can really make. And y is equal to 3 is my line. So I can just make a straight line that goes through that point, right? Just y equals 3. That is my line, right? It's just going to be a straight horizontal line, okay? A horizontal line that is flat like this does not have a slope, okay? This is what we call an undefined slope. No, this is what we call a zero slope. I'm sorry, yeah, this slope is 0, not undefined. Apologize. Flat horizontal lines have a 0 slope because your value for y is always going to be 3. No matter what point you choose on the x-axis, your value for y is always going to be 3. And so this has a 0 slope, okay? This is a special case. The case next to it is also a special case, and this is an undefined slope, okay? In this situation, we do not have a b, right, at all. There's no b, and because there's no b, we have a vertical line, and it never interacts with the y-axis at all. So it says x is equal to -2. My only point that I can really create is just here on this line, and I'm going to create a straight vertical line that goes through x is equal to -2. All right, that's my line. It's straight, it's vertical. There is no slope. It is undefined, okay? And it is undefined because it's vertical. So any line that is straight up and down, vertical, has an undefined slope. Any line that is horizontal has a 0 slope, all right? You do have to understand the difference between those two because you will be asked about something like that. So it's undefined if it's vertical, and it is 0 if it is horizontal. How do I know when I have one of those lines? You can look at the equations. The equations, if it says y is equal to just a number, it's going to be a horizontal line. If it says x is equal to just a number, it's going to be a vertical line. So when there's only one variable, that's an indication to you that it's a special case, right? And if it's x equals, it's vertical. If it's y equals, it's horizontal. All right, there's a way to remember this. All right, so this is the acronym, right, to help you remember horizontal 0 y equals, right? Vertical undefined x equals. Hoi flux. Not that anybody's going to remember that, but horizontal means that you have a 0 slope and you have y equals, right? That's why it's h0y. VUX is for vertical undefined x equals, right? Anytime you have a vertical line, the slope is undefined and you have x equals. Okay, so a horizontal line, 0 slope, y equals. A vertical line is undefined, x equals. Hoi vux. Okay, so with this, we have now seen the 4 different kinds of slope that you can have. You can have a negative slope that goes down to the right. You can have a positive slope that goes up to the right. You can have 0 slope when you have a horizontal line, or you can have an undefined slope when you have a vertical line. I really miss being in person for this because this is my only time I get to have a Vanna White moment. Those of you who are not familiar, Vanna White is the lady on Wheel of Fortune who used to turn the letters. Now all she does is gesture with her hands because it's all automatic. But she used to actually have to go around turning the letters back in the day. Now it's all automatic, but I love the gesturing. So I'm sad that we're not in person so I can gesture in person. But that's my dream job, just to have to gesture and show things off. Okay, so horizontal 0 slope, y equals, vertical undefined, x equals. All right, questions about the different kinds of slope. There are 4 different kinds of slope. All right, so in the chat, I want you guys to put in a kind of slope. Don't press enter yet, but put in a kind of slope. So put in one of the 4 kinds. There are 4 kinds of slope. Put in one of those 4 kinds into the chat, and then I'll give you guys a countdown, and then you can press enter. All right, so go ahead, write it into the chat, whatever your kind of slope is. All right, and then you can press enter in 3, 2, 1. Tell me a kind of slope. I have 2 responses. There are 6 of y'all. I only have 2 responses. 2 out of 6. That's a third. Okay, there we go. 3 out of 6. Okay, 4 out of 6. We're getting better. All right, only a third is missing now. All right, so remember that hoi isn't the kind of slope. 0 is the kind of slope, right? Just to clarify, 0 slope is the kind of slope. Hoi is just so you remember that when you have a horizontal line, it has a zero slope. But yes, 0 is a kind of slope. So we have 0, we have undefined, we have positive, a positive slope, and we have negative slope. Those are the 4 kinds: positive, negative, 0, undefined. All right, and I have, oh, already look at that. I had created a space for you guys to have this separately and I had no idea. I forgot about it already. But again, when you have your horizontal line, so that you can keep it in your mind like Homer. Homer is trying to remember it. Remember, I don't know if you guys remember that episode when Homer actually went to college. He tried. All right, so when we have a horizontal line, we have 0 slope, right? And it is always y equals, okay? That is going to be your equation. Y equals some number. When you have a vertical line, it is an undefined slope, and it is always x equals some number. Okay, that's your equation. All right, the way to remember that, I'm going to put it over here, again, is VUX and HOY. Horizontal 0 slope, Y, vertical undefined X. All right, so we have a couple of examples that we're going to graph using this idea. So this first graph is y equals. Is that going to be a horizontal line or a vertical line?
Horizontal.
Good. 1, 2, 3, 4, 5, 6. So we're going to make a horizontal line at y equals 6. I'm just going to count up to 6. 1, 2, 3, 4, 5, 6. And it's going to draw a line straight across. All right, I'm going to change my color so that it's better for the other ones. All right, so we have another y equals, we're going to have another horizontal line, this time at -1. So you're going to count from the 0, we're going to count down by 1, and you're just going to make a straight line going straight across at -1. All right, this next one says x is equal to 3. Because it's x equals, it's going to be what kind of line? Horizontal or vertical?
Vertical.
It's going to be a vertical line because it says x equals. So I'm going to start from 0, count over by 3, 1, 2, 3. And I'm going to make my vertical line. Ooh, I did not do a good job there. Oh, well, I tried. Okay. All right, x equals -2 is going to be the same idea. It's going to be another vertical line, but I'm going to do that at -2. So I'm going to start from 0, count over by 2 to the left, and make my vertical line. All right. Now in letters E and F, we have a little bit of a problem. Not really a problem, but we don't have y equals yet, right? We're getting there, but we have to get the y by itself. What do I need to do to get this y by itself? Right now it's being added to 5. how do I get rid of that 5? What should I do?
Subtract it
Perfect. I need to subtract 5
from both sides.
from both sides. So now I have y is equal to -5. Now I can graph that, right? That's my equation that I can graph. When it's like this, when the y is not by itself, I can't graph yet. Okay, so always make sure that your y is by itself. All right, so now I'm going to do my horizontal line at -5. 1, 2, 3, 4, 5. It's going to make my negative line go straight across there. Okay, and now the same thing for letter F. I have to solve that one before I can graph it. All right, so right now x is being subtracted from 3. So I'm going to do the opposite. I'm going to add 3 to both sides. Right, in this case, that's going to cancel out. I'm going to end up with x is equal
Basically, that'll be equal 4 then.
-1 plus 3.
Oh, -1 plus 3. No, take that back.
What's that going to be?
Not gonna be. If you had negative like that, you go way back. It will be negative. Be a positive 2.
+2. Perfect. Exactly. You're just 3 minus 1, right? It's going to give you 2. So that means I'm just going to graph this vertical line at x is equal to 2. Good work. All right, let's go do that right here. Oh, what happened to my line? Okay. Much better. All right. Any questions about your horizontal and vertical lines? All right, so always remember this, right? You're gonna have to put it into your brain, like Mr. Simpson here. But a horizontal line has a 0 slope, and you always have y equals a number. A vertical line has an undefined slope, and you have x is equal to a number. All right, we're going to continue to work with the idea of slope here by looking at what is called the point slope form. All right, so the point slope form uses your same y and x that you're used to. It also uses the same slope that you're used to. Okay, but it's also going to be giving you a point, and this point is supposedly on this graph, but you don't know the equation for the graph. So you figure it out by using this point slope formula. Okay. So you're given the slope, you're given the point, and then you have to figure out the equation. And this is what you use. You plug it into these steps or these parts. Okay. So what you have here in this first example, which was very poorly copied, but that's okay because you have a point here. It is -6, 4, right? Your -6 is your x, your 4 is your y, and your slope, what it should say here, is 1/3. Okay, so that is what you replace your m with. So you use this equation here, y minus y1. Your y1 is the point that you're given for y here, is equal to m times x minus x1. And again, your x1 is the point that you're given, right? So you replace it into here. All right, so that means you keep your y and your x just like you normally would, right? Those are never going to go away. You're always going to have those variables, but you're going to replace all the placeholders. Your placeholders are your y1, your m, and your x1, because you're going to have values given to you in each of those. So when I replace them, I now have y minus y1 is 4, so I just put the 4 in, is equal to m, oops, sorry, not m. I want to replace it with a number, excuse me. My m is 1/3 times x minus x1. So it's minus a -6. When I have two negatives, I just make it positive. So instead of writing -6, I'm just going to write +6, just to save myself that little bit of time. Right here, I have 1/3, and I have to multiply it to both of the things inside the parentheses. So I have to multiply 1/3 times x. When I multiply 1/3 times x, I'm just going to get 1/3 x, right? Which looks like what we're used to when we're looking at a linear equation. We have a part that we're like, oh, this is normal, looking better now. And now I have to multiply the 1/3 times the 6. When I multiply a fraction to a whole number, right? I have to make that whole number into a fraction. And then multiply straight across. I'm going to get 6 divided by 3, which is just equal to 2. So I have 1/3 x plus 2. Right? And now let me just bring down the left side of my equation, y minus 4. It's not an equation yet. I'm not done because I always want to get the y by itself. So I just need to add 4 to both sides. So my equation is going to be y is equal to 1/3 x plus 6. Okay, because 2 plus 4 gives me 6. These 4s are going to cancel out. And I'm just left with the y on the left. So y is equal to 1/3 x plus 6. All right, so point slope form, or this point slope equation, helps you when you are having to work backwards, essentially. So you're given the slope and you're given a point, and they ask you, well, what is the equation of this line? So this is what you do to work backwards. Right? In order to be able to use this equation, you have to know what the slope is, right? How to find it and what m means. And you also have to understand that this y1 and this x1 are quote unquote special. It's just that they are a point on that line. You have to replace those values with the numbers that you're given. But you always, always, always must protect the y and the x, because you need them to finalize your equation. Right, this is just the first example. We're going to take it slow and go through another one and see if we can get these points down and see if we're able to do it. All right. This, of course, is all worked out already here in this example here to the right. I just rewrote it again and worked through all the steps here in red. So when I erase, it's not like you're losing it because it's right here. The example is completely worked out right here. Okay. So we're looking at number 1 here, and it says a line passes through the point 2, 5 and has a slope of 4. So I have to write the equation given this information. Well, In order to get that equation, I have to use my formula. Y minus y1 is equal to m times x minus x1. But I have to identify my parts. So what's my m? What's my y1? And what's my x1? Right? Does anybody know any of these parts? What's my m according to the information that's here? What is my m?
4.
4. Great. What is my y1? Or my x1?
5.
Okay, my y1 is 5. Perfect. That means my x1 is 2. Remember that in these addresses, the x comes first, the y comes after, right? So now that I have all this information, I can put it into this formula. I'm going to keep my y and my x, but everything else is going to be replaced by a number.
Okay.
So y minus 5 is equal to 4 times x minus 2. Is everybody with me?
Yeah.
Okay. Now I have to distribute my 4. That means I have to multiply the 4 to both of the things inside the parentheses. So I have to do 4 times x, and I also have to do 4 times negative 2. What's 4 times x?
No.
4x.
4x.
Good. What's 4 times negative 2?
Negative 8.
Good. So I have 4x minus 8. Very good. Now I'm just going to bring down the left side of my equation. Okay, and now my final step is just going to be to add 5 to both sides. Okay, I'm getting pretty far down on my page. I'm just going to add 5 on top here.
So
All right, that's going to cancel out on the left. What's negative 8 plus 5?
-3.
Very good. So my equation is going to be y is equal to 4x minus 3. That is my equation. And that is the answer to letter A. Okay. What about letter B? I'm going to give you all 2 minutes to work letter B through on your own. You're going to do the exact same thing. You're going to use this formula and replace the y1, the m, and the x1 with the numbers that are in letter B, and then see if you can come up with the equation. All right, so I'm going to give you guys 2 minutes of silence. I'm not going to say anything. I'm just going to let you guys work through it and see if you can do it on your own. And then we're going to go over it to make sure that we can do it. All right, go ahead. Were you guys able to get a line? Anybody? Did anybody get a line? No? What was the equation? I mean, for the line. No? Nobody got a line? All right, well, let's try it. Erase these. All right, so since the line passes through the point -3, 1, and has a slope of 1/2. So what is my m?
One half.
Okay,
MS 1/2.
what is my y1?
Your one
One.
will be 1.
Good, and my x1?
Negative three.
Perfect, okay?
Yeah.
So I'm gonna put all of that information into this formula. So I'm gonna say y minus y1 is equal to m times x minus x1, which is minus -3. I'm going to change that immediately to just a +3. All right, and then my next step is just going to be to distribute the 1/2. So multiply it to each of the things inside the parentheses. So 1/2 times x is just going to give me 1/2 x. 1/2 times 3, which I can do it down here, 1/2 times 3 over 1 is just going to give me 3 over 2. Right, I'm just going to leave it just like that, plus 3/2. And now I have y minus 1, right? So I need to add 1 to both sides. This is where it gets a little tricky, right? Because you're adding 1 to a fraction. So the easiest thing to do is to turn 1 into a fraction as well. We have to turn it into a fraction with the same denominator that you're using, right? So instead of adding 1, I'm actually just going to add 2 over 2. 3 plus 2 is going to give me 5. So my equation is going to be y is equal to 1/2 x plus 5 over 2. Because I did 3 plus 2 to get 5. So y equals 1/2 x plus 5 over 2. All right, so hopefully you guys got at least to the point where you got 1/2 x plus 3/2. This other part here where we're adding 1 is a little challenging, but all the other points were a repeat of what we did before, right? Making sure you identify your items, your m, your y1, your x1, and then trying to plug them in to the formula. Okay. I'm going to erase this. We're going to try number 2. All right. So number 2 wants us to graph the equation, but we can't graph this equation because we're not done yet. We got to figure it out first. right? So we need to distribute first, right? We need to distribute that -2 to both the x and this -3. So what's -2 times x?
Be negative two x.
Good. What's -2 times -3?
Give you positive 6.
Good. So you have -2x plus 6. And then we have to just bring down the left side of the equation, y plus 6. We have to get rid of this 6. So we're just going to subtract 6 from both sides. That means it's going to cancel out on both sides. So what you're left with is y is equal to -2x. All right. So how are we going to graph this equation? Where are we going to start?
Jesus. So F1 and F1 equal to F first. Find the bar. Okay. No one. Yeah. How can I remember my y-intercept? Okay, if it y-intercept to.
So the first step is always to find the b, right? Where is the b in this equation? Y equals -2x. The b is always after the x value. So what's the b? What do we
There's no
see
B.
after? There's no b. So it's what? It's
0.
0. Okay, so we're going to start there in the middle at 0. That's going to be my first point. All right, what's my next step going to be to find my next point?
What was the question?
What do I do next? How do I find my next point?
You have to use the slope of rise over run.
Okay, good. So what's my slope?
2x. -2 equal -2x.
What's my slope?
-2.
Okay, good. My slope is -2, right? So I can also rewrite it as -2 over 1. So that means from that point that I just drew in the middle there, I'm going to go down by 2 and then to the right by 1. So 1, 2, and then to the right by 1, and I'm going to make my next point. Okay, down by 2, to the right by 1. Right, so I have enough points here that I can just connect my line. Okay. All right, so that's how you graph, right? So the last step, the third step, is to connect your dots, right? All right, so we're going to use the same strategy that we used for number 2 to complete number 3. Right, we have to solve the equation first, and then we can graph it. So we have to take this 2/3, we have to multiply it times the x, and then times the 4. All right, so we're going to get 2/3 x plus 8/3. So we have y minus 1 equals 2/3 x plus 8/3. Right, because 2 times 4 gives me 8, right? Now I'm going to add 1 to both sides. Again, I'm adding a fraction. I'm adding 1, but to a fraction, excuse me. So instead of adding 1, I'm going to add, using my denominator, I'm just going to add 3/3, because that's the same as 1. So now I'm just going to add 8 plus 3. That's going to give me 11. So y is equal to 2/3 x plus 11/3. All right. 11/3 is going to be a little bit hard for me to graph, but I know that 11/3 is almost 4. Because if I turn that 11 into a 12, 12 divided by 3 is 4. So it's close to 4. Just so everybody has a good understanding of what that's going to end up meaning. All right, so I have to use my b. I actually have a b now, right? My b is 11/3. So I have to try to find something as close to 11/3 for my first point. And then my slope is going to be 2/3. So I'm going to go up by 2 and then to the right by 3. All right, again, this one's going to be approximate because we're dealing with a fraction. When you're dealing with a fraction, it does not have to be perfect. No one is looking for perfection when it comes to a fraction. You just have to be as close as you can be. So I'm going to go up to almost 4. 1, 2, 3, 4. So it's 4 is here. I'm going to go just a little bit below 4 to make my point. And I'm going to go up by 2 and over by 3. 1, 2, 3. For my next point, I'm going to go just under 6, right? Okay. Up by 2, over by 3. And then I'm just going to connect my points from my line. All right, this is a situation in which if you guys at least just have the point, the equation, that would be enough because I know that this one would be very hard to graph. As long as you have the equation, you have the idea, I know what you're trying to get to. I wouldn't necessarily force you to graph this, but that's what you're working with. So that's 2 and 3. All right, let's do this last part here. We already did this part, so we don't have to worry about that. All right, so part 4 is the same as we did in part number 1. We're just practicing that same idea, but this is going to be a little bit different. Sorry, we're still creating the equation, but this time instead of given, we're not given the slope. We have to find the slope. So there is now another way to do these activities, right? So I've defined for you already that m is your slope, right? I've also defined that slope is a ratio. It is rise over run. okay? Well, there's also another way to define slope. Slope is also defined by this idea. So you define it as y2 minus y1, or the point, or the point in the y coordinate in one point minus the y coordinate in another point, divided by the x coordinate in one point minus the x coordinate in another point. And it doesn't matter which point is which point is 2 or 1, as long as you are consistent. So we're going to watch how this works. We're going to find the slope, right, of a line using 2 points. Okay, so for this first one, we're just going to call this point 1, and we're going to call this point 2. All right, this is point 1, this is point 2. What that means is that I have m is equal to -3, because that's y2, minus 0, because that's y1, divided by -2 minus -6. All right, I used this definition here, and I just plugged in my numbers. I called this point 1 and this point 2, and I plugged the numbers in. I have 2 negatives right here, right? I have minus, minus, so this just becomes a plus. -3 minus 0 is just going to be -3. But what is -2 plus 6? What's -2 plus 6? Anybody know? -2 plus 6? -2 plus 6? Good, I see it in the chat. All right.
Is it 4, Mr. G?
It is 4. Good. Yes, and I saw that Ebony put it in the chat. Good job. So it is 4. I'm going to put that in. So that means my slope is -3 over 4. All right, that is my slope. Now, let's say I switched it. Let's say I did it the other way, right? You're not making a mistake if you do it the other way. And by other way, I mean, if you call this one, this first point, if I call that point 2 and I call this point 1, all I'm going to do is switch my numbers, right? But it should give me the same answer. Let's see. So I'm just going to switch my numbers. It's going to be 0 minus a -3 over -6 minus a -2. All right, 0 plus 3 is going to give me 3. -6 plus 2 is still going to give me a -4. At the end of the day, I still end up with -3 over 4, because that negative is going to apply to the whole fraction, not a part of the fraction. It's the same thing. So order does not matter. It doesn't matter what point you call 1 or 2, as long as you are consistent. That means that you shouldn't be subtracting -2 from -3. You have to understand that that's x and it goes into the denominator and the y's stay in the numerator. As long as you're consistent there, you're always going to get the correct slope. Okay, so my slope is -3/4, and I have to use it to get my equation. So that's only the first part. The first part is getting the slope, right? You don't have to do it twice. I did it twice just to show you that it doesn't matter. You have to do it one time, get the slope, and then use the slope to get the equation, right? Using your point slope formula like you were doing before. So we're adding a step essentially to that first part, right? So our point slope formula again is this: y minus y1 is equal to m times x minus x1. So we have our slope. And again, we can use either one of these points. It doesn't matter which point we use, we're still gonna get the same answer. Because I don't wanna do extra math, I'm gonna use the point that has a 0 in it, right? Like, that means I don't have to add or subtract anything. It's gonna be much easier for me, right? So it's gonna be y minus 0 is equal to -3/4 times x minus -6. That's going to become a +6. I'm going to multiply this to both of the things inside here. I'm going to end up with y, because I don't need to do anything with that 0, right? So it's just y is equal to -3/4 x. I have to do 3 times 6, which is going to give me -18/4. I can reduce this fraction because I can reduce it by 2. I'm going to get -9/2. So my equation is y equals -3/4 x minus 9/2. That is my equation. All right, so we're going to do it again. We're going to find your slope first. We're going to use part B. You're going to find your slope first using this equation, right? I'm going to call this point 2. I'm going to call this point 1. Okay, so that means I'm going to do -3 minus a -4 over -5 minus a -6. These are going to become positive. So -3 plus 4 is going to give me 1. -5 plus 6 is also going to give me 1. So my slope is just 1. Now that I have my slope, I'm going to go back to this, right? The point slope formula, and use one of my points and try to find the equation. So I'm going to erase what I did here to get the slope, just so that I can now find the equation. All right, I'm going to use this I'm going to use this point, right? Doesn't matter which point you use, I'm just going to use this one for fun. So I'm going to do y minus y1, which is -4, is equal to 1, which is my m, times x minus -6. That's going to become a +6. This is going to become a +4, right? I don't have to multiply 1 times either of these. It's just going to be both of those, right? So that I can pretend that 1 isn't even there. But I have y plus 4 is equal to x plus 6. I need to subtract 4 from both sides. So my equation is going to end up being y is equal to x plus 2. You can check your answer to see if it makes sense, if it works, by putting the x value for any of your points into your new equation to see if you get the y value. So is -5 plus 2 equal to -3? It sure is, so it works. Okay, so there is a way to check yourself. You're just like, did I just do all this math and none of it makes sense? It does make sense because you do end up with the correct answer at the end. Questions, comments, concerns, and complaints? Speak now or forever, ever, ever hold your peace. All right, nobody spoke. I hate fractions. Yes, you are not alone. You are not alone. All right, so this is the last thing we're going to do today. We're going to look at how this plays out for real world problems. Okay, so we're going to create an equation. We're going to see how the slope helps us with that and how we actually use this. Even though it doesn't seem like we do use this in fees and how we actually get charged for things. All right, so there is a daily fee for renting a moving truck plus a charge of 50 cents per mile driven. It costs $64 to rent the truck on a day when it is driven 48 miles. All right, so write the point slope form of an equation to find the total charge y for any number of miles x for a 1-day rental. Okay, so what we have here, what we're finding out is that it costs us $64, right? Was the charge that we got after we drove it 48 miles, right? And that's going to include the charge for renting it for 1 day, right? There's a daily fee. We only rented it for 1 day, but in total for 1 day after driving it 48 miles, we got charged $64, right? So if we think about it, our 50 cents, right, is going to be the rate at which we are being charged. That rate is what our M is. That's our slope, okay? So a rate that you're being charged for something is the slope, all right? So you can identify that in kind of any equation moving forward, is that your rate is going to be equal to the slope, your M, all right? If I'm being charged per mile, my per mile, as you guys have been identifying these things before, my miles are going to be my independent variable, which my independent variable I always represent as my X. So my 48 miles are my X, and my dependent variable is what I've been charged, so that's my Y. So if I put that into point slope form, it means into this form here, right? I can replace the M with the 0.5, the X1 with 48, and the Y with 64. All right, so it'd be Y minus 64 is equal to 0.5 times X minus 48. All right, that's my answer for part A. All right. To do the answer for part B, I just have to solve this equation, right? To make it into Y equals. So I need to multiply the 0.5 to both of the things that are inside the parentheses. So I'm going to have Y minus 64 is equal to 0.5x, and then 0.5 times 48. Well, negative 48. What's 0.5 times negative 48? You can use your calculators. You can use your brain. If you remember that 0.5 means half. So what's half of 48? You ready to tell me? 0.5 times 48. Ooh, somebody wrote it in the chat. Let me see. 24. Perfect. So it's going to be negative 24 or minus 24. All right. So I'm going to add 64 to both sides to get the Y equals. So what's negative 24 plus 64? It's going to be a positive number. What's negative 24 plus 64? . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . Negative 24 plus 64. Nobody? Nobody? Negative 24.
Negative 24.
Yeah,
It
negative
doesn't want to be 40.
Yeah, negative 24 plus 64 is going to give you 40. So this is going to be your answer for part B. This is your answer for part A. This is your answer for part B. Okay. So now that we have this slope intercept form, we can identify the daily fee. The daily fee is going to be represented by your B, or your y-intercept, right? Your y-intercept in this case is 40, or your B is 40, which means that your daily fee is going to be $40. Okay, this is kind of just how all of this stuff plays out, as to why we actually do this kind of math and why this math is important. It's actually because it's math that we use, right? We actually do use it. Not that we're sitting at home calculating these things, but when you get charged certain ways and by certain fees, they use formulas like this, right? So every day it's going to cost you $40 to rent this truck, and then it's going to cost you 50 cents per mile. And so then you can figure out what your charge is going to be based on the information that you're able to collect and gather. All right. So that's slope, point slope form, and using your y-intercepts and all of those things. All right. So we don't have a lot of time to go over practice 1, but I will go over with you guys what is going to be due by 3 p.m. tomorrow. So there is just practice number 2, right? That's in here. This practice number 2 is going to be due by 3 p.m. tomorrow in order for you guys to get credit for the afternoon class. So what we did today was the notes. So make sure you turn these notes in as well, because all the notes are now done. But turn your notes in, turn it in practice 2 by 3 o'clock tomorrow. You have to do the notes. If you weren't here at the live class, you have to do the notes in order to get morning credit for today. To get afternoon credit for today, you need to do practice number 2. All right, and that is a worksheet. I think it's just a couple pages. It's not as long as practice number 1. And it just goes over how to use your slope and y-intercept. Okay, those 3 pages. All right. All right, so I will see you all next week for your final week of math class. We will just review.
Mr. G, are some of these problems like this going to be on the CASAS test?
So yeah, so there's going to be a couple questions where you have to identify slope. It's probably not going to be quite as in depth as what we just did with that last example, but you are going to have to be able to identify slope and be able to graph. Well, not be able to physically graph because you can't graph on the CASAS test, but identify the parts of a graph.
Okay.
Yep. Okay.
What about those that are taking their CASAS test this week? Will we still have that slope and
You're
stuff
taking
on
it. You're taking it next week, right?
No, I'm scheduled for this Friday.
This Friday with Dawn. Wow, Dawn is on top of it. Oh
I'm
my,
scheduled with
Come
those
on,
too.
yours on Friday.
oh my goodness.
Hold on.
Yeah, so
Yours on Friday.
there's probably going to be 1, maybe 2 questions. So if you're still uncomfortable with it, don't worry about it. It's not going to change your overall score. But it will be something that you see on the test.
Okay, all right.
Okay. Thank you, Mr. G.
Yep. No.
Thank you.
Thank
problem.
All
you.
right.
Good luck.
See
All
you
right,
all
see y'all
next
next-
week.
All right.